Hi, my name's Peter Willis. Don't know about you, but I've been aero modelling almost all my life. Now I'm a member of the British Model Flying Association Achievement Scheme Review Committee, and that committee's recently introduced tests for multi-rotors with FPV extension. And as an examiner, I could be asked at any time to do a test on a multi-rotor, so I'd like to understand a bit more about the technology that's involved, particularly the stabilisation technology. And as the British FPV Racing Association, in conjunction with the BMFA, are holding an event at Popham Airfield, I thought what a wonderful opportunity to go and learn a bit more about it. So I've given Duncan McClure a phone, and we're going to meet up there. Now Duncan's the controller for the achievement scheme in the UK, so we're going to meet up and see what we can find out. Hi Duncan.
Hi Peter, good to see you.
Nice to see you again.
Yeah.
Can you tell me why the BMFA introduced multi-rotors into the achievement scheme?
Sure. The Achievement Scheme Review Committee, who really look after the BMFA Achievement Scheme, like to keep up with the times. We became very aware that there were very popular classes of aircraft that lots of people were out there flying, but for which there was currently no provision within the existing achievement scheme. And that's really quite, we wanted to be helpful to clubs as well as members in terms of providing some measure of proficiency for these new types of aircraft, which is why over the last few years we've introduced the multi-rotor A and B and also the basic proficiency certificates.
Now there's a lot of examiners in the BMFA that have clearly been flying fixed wing for many years, never had any experience of multi-rotors, and I'm assuming that some of the members of the achievement scheme are those side of the people, so they didn't know a great deal about multi-rotors. In order to, so how did you go about introducing multi-rotors with that lack of knowledge?
Well, the important thing is the Achievement Scheme Review Committee, whenever we've got a new area, we like to pull in people with expertise in that particular area of knowledge. And that's what we did with the multi-rotors. We brought in a number of individuals to help us and give us guidance when we were preparing all the new schedules and documentation. So.
Okay, well we're here, where hopefully there might be some experts. Do you think we could find one to help us?
There are definitely experts here today. One of them is a chap called Chris Bradbury, and he was one of the leading individuals that guided the development of these tests in recent times. So.
Brilliant, let's go and see if we can find him and find out a bit more about these.
I'm sure we can.
Thanks.
Hi Peter, I mentioned earlier that we were going to find Chris Bradbury. Well, here he is. And the nice thing about Chris is he's a hobbyist, but also this is his profession. So we're getting a perfect mix of the professional view and the hobbyist view with regard to multi-rotor operations. So you can see why the ASRC asked Chris along to give us a hand when we were developing all of the multi-rotor and the BPC. The new certificates that we've recently introduced.
Yeah.
I'm going to ask him now some questions and ask him to take us through all the various stability modes that are available on a variety of the different multi-rotor machines that he's brought along today to show us. So Chris, I mean, first of all, thank you very much for coming along to the ASRC all those years ago and talking us through and helping us develop the various tests. But what we're here today, we're trying to get to provide really good video guidance for examiners, so they know what to look for when these things are operated in the various stability modes. So if you could just sort of talk us through all the various things that you taught the ASRC when we were developing these.
Well, I think the first thing to know is the difference between stabilised and self-stabilised. So for starters, a multi-rotor won't fly without some form of stability control inside. Okay. So they all have some form of brain which is talking to the four motors to control the speed, to essentially control the levelling, to fight the wind, to make it flyable.
Okay, so that's what we would term as flight enabling stability.
Flight enabling stability,
without that stability,
like having a flybar on a helicopter, or a three-axis flybarless unit for a flybarless helicopter.
Perfect.
So for this to work, the receiver needs to speak to the four motors independently. So if this wants to tilt right, these two speed up, these two slow down. And to create a yaw effect, or the rudder, you have two of these motors spinning clockwise, two spinning counterclockwise. So again, the brain is going to speed up two that are clockwise, slow down the two counterclockwise to make it rotate in the relevant direction. What you then get beyond that is self-stabilizing modes, where the aircraft brain can essentially work for you. So this is a fully manual aircraft. If I tilt this over to 30 degrees with my controller and let go, all the stability on board will do is try and hold that angle. So it will just keep drifting off. And much like a normal radio control helicopter, if I was to bank it and let go, it would just slide down into the ground.
Okay.
If you then get the next level up, which is a self-stabilizing, which is quite often referred to as ATI mode from DJI software, so things like the Phantom 4 F550s, which we have on the floor here. The ATI mode in that is when you push the aileron on this, it will completely roll over, like any radio control model. What ATI will do is it will lock it to an attitude, and that's why they call it ATI. So you tip it over, and if you were holding the full aileron all the way over like that, the aircraft would only go to about 40 degrees.
Okay.
And then when you let go of the transmitter and it resets, it will self-level itself.
Okay.
So that's your first sort of level of stability mode.
An examiner could tell that that mode was activated by asking the candidate to
Just let go
those.
of the sticks.
Yeah,
Put a
okay.
small movement in, sort of 10 or 15 degrees. When the candidate releases the stick, if it does that and self-levels, then it's in a stabilised mode.
Okay.
If it stays at the 10 degrees, then it's in what we should class as manual mode. So yes, it's stabilised, but only for the purpose of flight. You then get GPS, and the way to tell the difference between ATI and GPS, because they essentially fly the same, is in ATI mode, I said you can't tilt it more than 40 degrees.
Yep.
The same applies to GPS. Now, if I was to tilt this at 40 degrees and let go in ATI mode, it would just carry on drifting off with the wind. What GPS would do is snap and stop and try and locate a position.
Okay.
So it would stop it going anywhere else.
So again, a good way for an examiner to be able to
Yeah.
tell whether that mode's been activated, inappropriately perhaps.
Yeah, is if it's drifting and they let go and it carries on drifting horizontally, it's in ATI. If it stops dead, it's in GPS. If it stays tilted, it's in what we class as manual mode.
Okay, perfect. Okay, Chris, so what other stabilisation modes are available too?
There's various different
Multi-rotor
ones.
flyers.
When you get to this is probably the higher end of the hobby market before you go into the professional level. This has GPS on the top here, which is what this little mushroom antenna is for. And what this can do with the GPS is intelligent orientation control. And essentially what you can do is create an artificial north. So once you've taken off and you're positioned, the camera here would normally be my nose. So if I put it into that position and switch into intelligent orientation control, if it's now facing that way at 90 degrees, if I push forwards, it will go the direction the nose was.
Okay.
So essentially, if you think about flying a rectangular circuit, you could go right, forwards, left, backwards, right. But the aircraft could be whichever way it wants to face.
Right.
So it's a way of cheating for circuits on some people. Other flight modes for this is waypoint positioning, and especially when you get up into the commercial one here, you've got things like cruise control. This can be programmed, or both of these can be programmed through an iPad. So you put in the waypoints, click go, takes off on its own, flies a waypoint circuit, comes back, lands.
Okay.
So zero input from the pilot.
Scary stuff. Yeah.
Yep.
Okay, Chris, maybe now you could talk us through the various flight modes and return to home and
Okay.
safety modes, sorry, fail-safes.
Fail-safes. Well, starting with this one, because like I said earlier, this is fully manual, there's no stabilisation on this one. The fail-safe for this would be the same as normal fixed-wing aircraft, which is throttle to idle and let it fall down out of the sky. So something like this, you never fly too close to people, so, you know, inside netting, for example. When you have an aircraft with GPS equipped like this, you then have the facility for things like position holding, returning to home. So you could set a multitude of options for this, where you could have the aircraft loiter, where it would just stay still, so it won't go anywhere, it would just stay in its position. That gives you the option to walk towards it and try and regain control. You can then have descend and land, so it will just come down where it is. Really good if you're over a lake. Then you can have return to home, and most of the return to homes you can have it turn around, face you, or just come back the direction it's facing.
Okay.
So I normally have the aircraft turn around to face me to fly back, and that's a personal preference for me, because with the switches I can override the fail-safe. So if I know exactly which way it's facing, I know which way to take control when I do, if that makes sense. Normally on your switch, on your transmitters, you'll have various three-way switches or two-way switches. So for example, with the small one there, it's in acro mode, fully manual, but I can click up there and get high rates, same as you would with a normal model.
Yep.
I can then go into this one to make it self-stabilizing. You can also do fail-safe return, so if you incapacitate, just hit the switch and it will come home.
Okay.
So all the fail-safes will work the same way. If the transmitter switched off, they'll automatically arm however you've set it. So if you've set the fail-safe to descend, switching the transmitter off will make it descend.
Okay.
Yeah. But you can also then manually enter it.
I think that's really useful for you going through all those things, because a key element of the test is for the examiner to be happy that the candidate understands how to activate and deactivate all of those various controls.
Yeah.
So this is actually a very important element of the various multi-rotor BPC and the BPC tests.
Yeah.
So.
I mean, this is my hobby transmitter, so I don't have it on here, but the commercial one, I have red heat and shrink round the switch,
Okay.
and that's my failsafe switch. So all my crew are told basically on the day when we're filming, if anything happens to me, hit the red switch, because
Cool.
then it'll come back and land.
Yeah,
You know.
understand.
But again, like you said, the pilot should know which switch is his gyro gain to make it more sensitive, which one puts it into ATI mode or GPS mode or manual mode,
Yep.
which one does the failsafe, yeah,
Okay.
various different things.
And I think the other important point to make here is for the multi-rotor A and B tests, other than flight enabling stability, no stability modes are permitted during the test.
Yeah.
But for the BPC, the basic proficiency certificate, all of the various safety modes are permitted. So.
Yeah.
Okay, Chris. Maybe now I wonder if you wouldn't mind talking us through the various types of machine that examiners might encounter, but
Okay.
also the sort of the multiplicity of various different controllers as well. That would be,
Right.
I think that'd be really useful.
Okay, well, if I start with this one, this is probably the most common I see around anyway, and it's a 450 size quadcopter. And when you say 450 size, it's the dimension from motor to motor diagonally, so it's 450 millimeters across. This is one of my earliest ones, and I don't know if the camera can pick up the brain inside, but it's basically just a 55 millimeter square circuit board with a couple of accelerometers on. And the accelerometers are what you'd get in your mobile phones for when you're using some of the apps, so it senses the direction and motion of the phone. It's exactly the same thing in here. So if I pick up this one, which is my earliest board that I ever programmed, this is actually an old games console controller which has been dismantled to use the accelerometers to fly this. This one here is a tricopter. So compared to the quadcopter, obviously one less motor, but the key difference is on a tricopter, you now have servos. So this is controlling the tail motor, and this will let the tail rotate. So on a quadcopter, you can slow 2 down and speed 2 up to get yaw. With this having 2 motors spinning one way, one spinning the other way, it always wants to yaw. So you'll find when it hovers, it's actually slightly offset, and obviously that flies more that way, that flies more that way. So it can give you the rotation. I would say in terms of what I would expect to see at a club, there'll be a mixture of control boards up to control units. The control unit in this one here is very high end, it's about £1,000, so it's going to put off most of the hobby market. Okay. The unit in here, however, is about the size of a matchbox, and it's sort of 5-6 centimetres. And essentially what that does, it takes the signal from the receiver and translates it into the 6 motors. And with the unit you get in here, you plug it into a laptop or a computer, and you tell it what configuration of aircraft you're going to fly. So is it a quadcopter? With quads, they can be flown as an X, which is where you have 2 motors facing the front, or as a plus. Okay. So you have 1 at the front. The other things that the unit will do in here is all the flight modes that we were talking about earlier. Now, the unit that's in here is the same as you'd get in a DJI Phantom.
Okay.
And when they come out of the box, they've got a little bit of controlness to them in terms that they can't fly in manual. So DJI Phantom, for example, straight out of the box will be attitude mode, and GPS on the freeway switch. If you want to put it into manual mode, you have to plug it into a laptop and put it into manual mode for the first phase of that switch. Whereas the other end of the scale, which is where you get these kind of 50mm circuit boards, much like you get in the racing quads here, their default is manual. And it's whatever software you put onto it through applications such as Clean Flight, which is a Google Chrome software, or Base Flight. Whereas the units in there, that's DJI software and it's DJI units, and it's all plug and play. One thing that's worth noting is we get through the club I've had is people with DJI Phantom saying I can't loop it because it won't let me. All the control units will have some way of interacting with a computer. So for example, on the back of this one here, I have a little LED unit. Okay. And this does a couple of things. In flight, it will blink LED modes at me to tell me what flight modes it's in. So with this one, if I'm seeing an orange flash, then I know it's in attitude mode. If I'm seeing a green flash, I know it's in GPS. If I'm seeing 2 oranges, it's in ATI mode, but the throttle's not in the right position. So it's knowing the combination. So for example, again, a green flash for the GPS followed by 3 red flashes means it's not reading as many satellites as maybe it should be. Okay. And on the bottom of there is a USB socket. So you plug it straight into your computer, reprogram the software. Okay.
That's interesting that the Phantom can actually be put into manual mode, should you need to do so.
Yeah, I think the main thing with things like the Phantom is it's this whole stabilised camera platform.
Yes.
It's not an aircraft you're necessarily going to be doing aerobatics with, they're marketing it as an aerial camera platform.
Yep.
NASA V2, which is in there from DJI, straight into one of these, and it basically do everything a Phantom will do, just without the fancy body in the camera.
Yeah. I think the most important thing is that examiners appreciate that there's a variety of different
There's a multitude
machines,
out there.
that people could actually bring. So that's the whole purpose of this video, is to be able to try and get some knowledge and understanding across about. So because I wouldn't know how to have assessed all those various modes until you told us. So, and one of the other things that I guess we should say is that later on in the video we're actually going to be seeing all these machines fly. So we're going to see these various modes demonstrated, so I think that's important.
I think one thing as well, when it comes to sort of assessing, when you look at sort of basic control boards where you've had to program software onto it, the person's probably a lot more invested into knowing how it works.
Sure.
Whereas the units that come out of the box pre-programmed and you just plug it in and it's almost plug and play, something like the Phantom, reading instructions and then flying it is different to actually knowing how it's all put together.
Absolutely. Lovely. Thank you very much.
Before I start this, one of the things that's important to know as well with some of the control boards is how to arm them. So a lot of them will have a failsafe. At the moment this is doing absolutely nothing, and it's because I have to do a movement with the sticks. Now quite a few of the NASA stuff and DJI, it will be both sticks down to the corners or both sticks to the left or both sticks to the right. It'll all do the same job, so I just go out. Some of the more basic boards, it's just down and right on the rudder, for example, and then down and left to disarm. What you can do, which I do with my racing quad, because they crash quite often when you're trying to get through gates, is I have it on a switch. So I hit a flight switch and that's my arming setup. So just checking the last couple of things on that. Right, I am good to fly. So last thing I check is my LED status on the aircraft to make sure I've got the right light flashing. And then what I'm going to do is I'm going to take off in stabilised mode, put it straight into a GPS lock, and you'll just see what it's like. So to arm, it's both the sticks down and it's ready to go. And just quick punch up, and that's now basically a hands-free GPS hold. So if the aircraft's capable of doing that, then you know you're in GPS. If I now switch it into the ATI mode, it's just going to drift off with the wind. So all it's trying to do is stay horizontal. So that's the wind carrying the aircraft away. If I flick into GPS, it will just take over and stop. So I've not had to put any stick input yet. Now, in all of these modes, I can fly the aircraft around, and with my throttle on this one, all I'm essentially doing is controlling height. So if I push the stick forwards, it will ascend. If I let go of the stick and let it center, it will hold that altitude. So this is when the aircraft's completely taking control for me. So to descend, I pull back, and again, if I let go, it will stop descending. This has got retractable legs, which is nice. So if I put this into ATI mode now, and bank the aircraft to the right, this is full aileron. If you look at the transmitter, it's not going to go anywhere. If I let go, it will just carry on drifting. Yep. So if I now do the same thing and bring it back, and what I'll do is now we'll do the same thing again in GPS, and you'll see what happens when I let go in GPS. So this is in GPS mode. If I let go of the stick, it will stop and hold its position. So what I'm essentially doing in GPS is nudging it around the sky to a new position. So here, I'd move it over to the right, and as soon as I let go of the stick, it just stops where it is. So that's those two modes there, essentially, attitude and GPS hold.
You could see the GPS holding it against the little bit of turbulence in the wind earlier.
What we could do with this, if I put the legs down and just fly a little bit away over here, this is what would be classed as failsafe. So at the moment it's in GPS hold, it's got a comfortable lock, and if I was to lose signal, I could do, this would be the equivalent of loiter, and it would stay put.
Okay.
And this would be a deliberate failsafe now. First thing it's going to do is go up 20 meters or 25 feet, facing, it's turned around to face us, and it's going to then fly back towards where it took off from, and hopefully it will land right next to your GoPro. So at the moment it's just now shuffling through the sky, trying to find its GPS takeoff point. And once it's happy with that, it will start to descend. So this isn't me.
Excuse me, have you got video on? You have to turn off.
It's on 2.4, it's on a different frequency, so I'm fine. So this is, again, this isn't me, this is all autonomous. So what it will do is it's slowly descending, and it knows where its rough altitude was. So it will start to like feel for the ground. And then once it's happy with that, it'll switch everything off. So,
Impressive.
as you were there. So this one arms on a switch. The thing is with this is only manual, so very, very agile. So in terms of a loop, if I do a bad loop here, what I'm doing is basically just pull back on the elevator like you would with a plane. Okay. And what you'll see is you come in, that's not a loop, but that's what would happen if you tried to loop it like a plane.
Okay, that looked more like a flip to me.
It's exactly, it's a flip. So flying in, build up the throttle, up and over the top, catch it as you come out.
Lovely.
Hi, well I hope you found this video of some use. If you did, let the Achievement Scheme Review Committee know about it, because we'd like to be able to help examiners and learners to gain more knowledge in order to achieve a consistent approach and a safe approach to flying models of all types. So if you think it's been of some use, let us know. Bye for now.